In the open organ pipe or the closed organ pipe, whatever maybe that is a pipe, it's going to be the stationary waves that are going to be formed inside this one. So what do you call and this open organ pipe means? An open organ pipe is the one which consists of the a pipe, an organ pipe, which is open at both the ends. So in this one, we are going to generate an wave or a stationary wave. One will be an incident wave, another one is going to be a reflected wave conditions. So wave is going to be traveling in this direction and it's going to be moving in this way, and the reflected wave is going to be reflected from the surfaces at the open end and it's going to be come back. So this is how it's going to be taken. The length of the pipe is going to be something as an L. Okay, now the distance between these points are called as a nodes. Where the amplitude is minimum, those points are called as a nodes, and where the amplitude is going to be maximum, those locations are called as an antinodes. So the fundamental frequency in the open pipe condition is going to be the fundamental frequency is, that is F is equal to V by lambda. So now if we go for the lambda, that is a wavelength where only one loop is being possible in this case. In this situation, if I draw that particular thing here, that is if one loop, how the one loop single loop will be formed. So it will be in this order or this will be like this. Okay, so if I go like this is the one. So one antinode will be formed and two antinodes are going to be formed at the edges. So this is the node and two antinodes. So distance between your antinode and an antinode can be taken as an lambda by 2. So which is the distance in your wavelength conditions. And the distance between the node and the antinode is lambda by 4. Now the total length of the pipe is being taken as L in that sense. So you can equate that length L is equal to lambda by 2. From this one, the wavelength can be written as an 2 times of the length of the pipe. Okay, then the fundamental frequency of this one, that is F naught in an open argon pipe, can be written as an V by 2L, where V is called as an velocity. V is called as an velocity of sound. So depend upon the situation, the velocity of the sound value will be provided depend upon the temperatures and the remaining things. Now this is your first loop formation where you have required only one loop. Now in this case where the two loops are being formed, where the distance between the node, antinode and the node is lambda by 4 here, and the distance between the node and the node, as we know, it is lambda by 2. So in this case, it is going to be the distance between this is lambda by 4. So in this situation, the total length, that is L, is nothing but an lambda by 4 plus lambda by 2 plus lambda by 4, which is nothing but an 2 lambda by 2, or lambda is equal to 2L by 2. So this is called as your second harmonic, or the two times of the fundamental frequency, which is 2V by 2L. F naught, this is F1 is equal to 2 times of F naught. And this is called as your fundamental frequency, or it is first harmonic. Okay, and this is called as an second harmonic. So the higher orders of the frequencies are being termed as an harmonics, and simultaneously the second harmonic is also being termed as an first overtone. The second harmonic is called as an, this is the first overtone, in the sense that is your third one, or if I take it as an F2, this is an F1 itself. And your third harmonic, which is can be written as an 3V by 2L, where the three loops are going to be formed inside the pipe, where the resonance is going to be occurring over there. This is going to be the three times of the fundamental frequency. It is called as a third harmonic, or it is second overtone. Okay, so like this, the frequencies in the open pipe will be in the ratio of the 1 is to 2 is to 3 is to 4 is to so on like that. So this is the frequencies at the nodes at this particular points at this particular nodes where the pressure is going to be the maximum. So for the incident waves, the pressure at that particular points can be taken as an P naught, that is atmospheric pressure, plus delta P, that is an pressure variations of the pipe conditions, that is delta P can be written as an the value of the delta P is equal to A, that is amplitude, displacement amplitude into, that is a K into bulk modulus. K is called as a propagation constant. For the reflected wave, this is for the incident conditions. For the reflected wave, it will be the P naught minus delta P. It will be, this is the minimum value of the pressure and this is the maximum value of the pressure that will be existing at the nodes. So within a loop over here, suppose if you take this particular loop, so within this particular loop, what will happen is the energy is going to be maintained or contained within that particular loop. It's not going to be varied. It's going to be converted from one form to the another form over there. That is the kinetic energy and the potential energy formations. Okay, so this is regarding your open pipe. Now, in the open pipe also, actually speaking, we are taking the distance of the lambda by 4 from the edge of this particular pipe. But due to this pressure variations, your actual antinode might be formed out of this particular pipe. Okay. But this particular distance is neglected. We are not considering this particular distances, and that is called as an E. And where E is called as an end correction, where E is called as an end correction. So if you also consider this end correction, then the fundamental frequency in the open pipe can be written as an, this is going to be 2 times of L plus E. And the relation between the end correction and the radius of the pipe can be written as an E is equal to 0.6 times of the R. And if I replace that one, then the fundamental frequency will be turn out to be the 2 into L plus 0.6 R, where your R is nothing but a radius of the pipe, of the organ pipe or whatever it may be. Okay, so this is the fundamental frequency with respect to the radius terms and in terms of the end correction also. And open pipe will be in this particular ratios of the frequencies, please. So please be careful of this one. Your second harmonic is called as a first overtone, and third harmonic is called as a second overtone in the same sense. That means nth overtone means nth overtone means it is equal to the n plus 1 harmonic. N plus 1 harmonic. Okay, so this is your relationship, please. So now coming to the sum on this one, the fundamental frequency of an open organ pipe is equal to the third harmonic of a closed organ pipe. This is the one. So fundamental frequency of open organ pipe is equal to the uh, is equal to which one? Open organ pipe is equal to the third harmonic of the closed organ pipe. So here in this question, he has discussed about the open organ pipe as well as the closed organ pipe. But just now we have discussed only the open organ pipe. I'll discuss the closed also and come back to this particular question. Now coming to the closed organ pipe, this is an organ pipe where one of the side is going to be closed here. So this is your pipe where one of the side or one of the openings is being closed and only one end is being open. So when that wave is being generated and sent into this particular pipe, it's going to be taken over here. This is going to be the single loop formation. It is going to be the fixed edge. This is going to be incident ray, and this will be your reflected ray. As I have told you, the pressure at this particular point will be the for the incident ray, it will be the P naught plus delta P, and whereas for the reflected ray, it will be the P naught minus delta P. Delta P for this particular ray, this is the pressure, and for this ray, it will be the pressure, and the pressure at the open side of this is going to be the atmospheric pressure. So let the length of the pipe is going to be the L. This is going to be your antinode. Since it's a closed end, always we'll be obtaining a node. As we know, the distance between the node and the antinode is going to be the lambda by 4 here, and which is equal to your length of the pipe. So length of the pipe is equal to lambda by 4. In this situation, you can take the lambda is equal to 4L. So now when we substitute in the frequency relation, frequency is equal to velocity of the sound by lambda. That's going to be the V by 4L. This is called as your fundamental frequency, fundamental frequency of closed pipe. Okay. So now what will the next resonance or the next loop? What will be the next situation in this one? So next, if I allow the for the same length, if we adjust the wave such that you are going to take the two loops inside this, that is 1.5 loop. This is going to be a complete loop over here, and this will be your another loop here. Okay, so now this is going to be the two nodes are going to be formed here, and this is an antinode. So total length is being divided into the two parts. One is node to node is going to be the lambda by 2, and node to antinode is going to be the lambda by 4. Then your total length for the second situation, for the second case, can be written as an L is equal to lambda by 2 plus lambda by 4, which comes out to be the 3 lambda by 4, and the lambda is equal to 4L by 3. So in this way, the frequency is going to be, or the F2 is equal to, this is F1 or your fundamental frequency. Here F2 is equal to, if I substitute in the V by lambda, it is going to be the 3V by 4L, which is equal to the 3 times of the fundamental frequency, which is called as your third harmonic. Since you don't have the two existence here, after the V by 4L, it will be the 3F. So it's called as the third harmonic and your first overtone. Okay, so now the first overtone in the closed pipe will be your third harmonic. Similarly, for the third case, if it is F3, it will be the 5E by 4L, or which can be written as an 5 times of the F. So they will be in the ratio of 1 is to 1. This is called as an your second overtone, and the same thing is called as an fifth harmonic. So they will be in the ratio of 1 is to 3 is to 5 is to 7 is to 11 is to like this. Okay, so sorry, 9 is to 11 is to so on like that. It will be in this particular ratio. Okay, so skipping these even numbers, that is 2, 4, 6, 8, 10 like this. So this is your fundamental. This is your third harmonic, fifth harmonic, seventh harmonic, ninth harmonic, and the 11th harmonic. So 11th harmonic is called as what? This is your first overtone, second overtone, third overtone, fourth overtone, and this is your fifth overtone like this. So they will be flowing or following in this particular manner. So now as we have discussed the formula, I'll come back to this some again. So coming to this question, what is fundamental frequency of an open pipe? What is the fundamental frequency of the open pipe means? V by 2L. Okay, 2L, not let us take this one, is equal to third harmonic of closed organ pipe. Third harmonic of closed organ pipe means it should be the 3V by 4L of the closed one. Okay, this is the condition. So since the velocity, what he is asking, length of the closed organ pipe he has given, that is LC value provided 20 centimeters. Length of the open organ pipe he is asking. At L naught value he is asking. We remove the V here, please. So this goes for 2 times here. From this one, you can write it as an 1 by L naught is equal to 3 by 2 times of LC. What is your LC value? Is 20 centimeters. So that implies L naught is equal to 40 by 3. So this goes for 1 time. Left out 10, that is 13 point something. So it will be 13 point. Nearest option is 13.2 centimeters. So this is how you can find out, or you can. So while doing this sums, you should be very careful of the harmonics and the overtones of the closed pipe and as well as the open pipe conditions. Okay, so that is a very important situations, please. Now, in this case, an air column closed at one end and open at other. So there is an air column which is closed at one end and open at other end. What do you mean by this one? He is discussing about an closed pipe with us. So closed pipe is the one which will be open at one end and closed at other end conditions, please. Okay. So this is the case, please. Now in this one, at this resonates, he is asking that it has been resonates with the tuning fork when the smallest wavelength of the column is 50 centimeters. That is the smallest wavelength of the column is this is 50 centimeters in the sense only one only one loop is being forming. That is the minimum wavelength for a closed pipe will be your lambda by 4. So that is length is equal to lambda by 4 here. Okay, at this particular point, you will be getting an stationary loop or single loop where node is going to be forming, antinode is going to be formed here. The next larger length of the column resonates with the same tuning fork. So he is asking next resonance where it's going to be occurred. So next resonance will be occurred in this case where this is the closed end for you and this is the other end is going to be the open end. Next resonance occur when in this particular situations. That is where the length is going to be the 3 lambda by 4, that is 3 times of the your basic shortest length. That means 3 times of the lambda by 4 means what's the next resonance, which is 3 into 150. Theoretically, it's going to be happen, which is going to be the 150 centimeters. So theoretically, you can say that when the first resonance is going to be occurring at lambda by 4, second resonance is going to be occurring at the 3 lambda by 4, third resonance can be occurred at the 5 lambda by 4 like this, and so on. So these are the lengths where the resonance can be occurred over here. So the corresponding solution or the answer for this one is going to be this one, okay, 150 centimeters. Now coming to the beats. So beats is a concept where it's a very thinking it's an easy and also a tricky one basically. So what are beats? If you go for the what do you mean by the beats? So when two progressive waves of nearly same frequency, of same amplitude and same wavelength. So lambda amplitude, this should be the same but differ in the frequency. Okay, and in the that they should be in the same phase when they are moving in the same direction. That means if I take the first equation as a y1 is equal to this is a sine of omega 1 t your first wave and y2 is equal to a sine of omega 2t is your second wave, where the frequencies omega 1 can be written as an 2 pi f1 and omega 2 can be written as an 2 pi f2 in this particular case. So these are basically since these are the frequencies which have been slight difference in the waves, that is f1 and f2. So when these two waves traveling in the same direction superimpose on each other, then you'll be getting it as an y1 plus y2. So on that sense, they are going to be superimposed. That is A into, it will be the sine of omega 1 t plus it will be the sine of omega 2 t. And this is in the form of sine c plus sine d. In the sense, this can be written as a 2a into sine of omega 1 plus omega 2 by 2 into t into cos of omega 1 minus omega 2 by into this one. This represents the beat frequency, that is omega 1 minus omega 2 into t. This entire thing is going to decide the amplitude of the beat at that particular point. Where do we use this particular beats? Beats are being that this phenomenon can be utilized in the case of mixing of the nearly equal frequencies to form a single wave. For example, when in the music is being given, so in that particular thing, you might be hearing different music or notes from the different instruments. One from the guitar, another from the tabla, another from the piano, or whatever it may be. So the what does this technical person is going to do? He is going to mix up all these waves into a single wave so that that combined wave is audible for the human being. So this mixing is nothing but called as a combining is called as an beats here. Okay. So and your beat frequency can be written as an. So in the sense, if we go for a generalized diagram, small diagram, let's try to get that particular thing. So this is your first wave of the frequency F1. So this is your first wave, sir. I'm taking here. And this is your second wave with a slightly difference in the frequencies. You can observe that one as the wavelength is been reducing, so frequency is going to be the more. When these two waves are being superimposed on each other, you will be getting an alternatively maximum and minimum like this. So this is where the minimum is called as an waning and maximum is called as an waxing. So this alternatively maximum and minimum conditions are called as at this point is called as an waning. This alternatively waxing and waning is called as an one beat. Okay, and your beat frequency can be obtained as a beat frequency is obtained as, so it has been that is delta f for the beat frequencies per second is equal to f1 difference f2, that is greater value of the frequency minus smaller value of the frequency. A human ear can only he can only identify up to 10 beats per second. Okay, and the persistence of the hearing of the sound, or that means the time the beat or the wave sustains in the human ear is going to be the 0.1 second. So he can observe or he can identify only 10 beats per second. So, and the time between the two waxings, that means maximum and maximum. So time between the two maximums is nothing but than 1 by f1 difference f2. This is between the waxing and waxing. And time between the waxing and immediate waning is going to be the half of this one. That is f1 difference f2 which between the waxing and waning. Okay. So this is our situation, please. So that's the main important thing. So these are the important relations. So you need to remember this one. It's a tricky thing basically to identify the beats, please. What is the trickiest part in this particular case? So I'll just try to give you an example. Based upon that one, we'll try to go for it. Okay, for example, there are the two tuning forks. Okay, there are the two tuning forks are there. Okay, now one is A, and the frequency of the A is going to be the FA. Another is going to be the B. The frequency of the B is going to be the FB. Let the value of the frequency is going to be the 256 hertz, and you need to find out the value of the B. Okay, this is the simple thing. Now, initially, number of beats produced are initially number of beats are some, let us imagine, some 4 beats per second. Now, before going for the sum, I just want to tell you one thing. First one, when tuning fork is tuning fork is waxed. What do you mean by tuning fork is waxed? That means on that tuning fork you are pouring the wax or melted wax you are pouring on the tuning fork. Because you are pouring that particular wax on the tuning fork, the thickness of the prongs will be increased. Because the thickness of the prongs are being increased, the frequency of the tuning fork will decrease. And simultaneously, if tuning fork is filed, tuning fork is filed. So filed in the sense, what do you mean by filing? That means you are removing a layer from that one. Because of the filing, what will happen? The frequency of the tuning fork will become, because the prong size will be reduced. Now coming back to the sum, this is a sum when both are being A and B are being vibrated here. You are getting the 4 beats per second. Now B is filed. So B is filed. When B is filed, number of beats are being, that is new value of the number of beats came down to the 2 beats per second. Okay, 2 beats per second. Then we need to find out the what is the value of the B. So in this type of the questions, you will have the answer in front of you. That means this is the formula. That is, beat frequency should be either equal to the two cases. That means if FA is greater, then 256 minus FB should be equal to the 4. Okay, like this is a condition if FA greater than FB. In this case, this is the answer. So FB should be how much? FB should be equal to the 252. This should be your answer. Okay, or what is the possibility if FA is going to be less than FB? Then the same equation should be written as an FB minus 256. FB minus 256 is equal to 4. So that shows you the FB value should be equal to the 260. So your answer is in front of you. It is either 252 or 260. Out of these two things, you have to choose one thing. So that is the logic of this particular. Your answer will be in front of you, but which answer you have to choose? That's the main important thing. Now here, read the question now carefully. When B is filed, that means when you are removing the layer of the B, what should happen? Its frequency has to be increased. Even though you are filing the B and frequency of the B is increasing also, still your result is decreasing. That means coming down from 4 to 2. That means it should be definitely that FA should be greater than FB. So in this case only it can be possible. How, sir? So as you are, FA is going to be your 256. The decreasing the number of beats is going to be the 2. That means beat as it is been filed, beat frequency has to be increased. That means new value of the FB dash should be equal to the 256 because there is a decreased by 2. So here it should be increased by 2. So if I place here 252, then obviously it will be equal to 4 that we have verified. And for the new case also, 256 minus 254 here, sorry. 256 minus 254, which is equal to 2, which is justifying the information that is given in the question. So you have to do in this way such that you whatever the result that you will be getting that should be justify the information which is given in the question. So please be careful while doing the sums in this particular beat concept. Okay. Now coming to this one where the such 50 tuning forks are arranged in an increasing order. There are the 50 tuning forks. First tuning fork, second tuning fork, one, two. This is your third tuning fork. Like that, there are how many, sir? 50 tuning forks are there. That means how many gaps will be there, sir? Total, there will be how many gaps will be there? 49 intervals will be there. Why I am taking this one? Just now we'll be observing. So, in this such that 4 beats are being per second. That means if I vibrate the second and first, how many beats I am getting? 4 beats. Third and second, 4 beats. 50 and 49, how many beats? 4 beats. That means how many fours are there from between the 1 and 50? 49 fours are there. If the frequency of the last tuning fork is octave of the first one, octave is a word that is used in the musical thing, musical terminology. So one octave means octave basically. One octave in the sense it is nothing but a 2 times of your fundamental frequency or the basic frequency. So here what he has given is higher frequency, the frequency of the higher is equal to 2 times of the lowest frequency. That means 50th frequency tuning fork is equal to 2 times of the first frequency. I think this is the information given. Then find the frequency of the first tuning fork. That means if I go for the difference between, if I write F2 minus F1, number of beats are 4. Okay. If I write F3 minus F2, number of beats will be how much? 4 only. If I write F3 minus F2, F1, number of beats are going to be the 8. Difference is going to be the 8. That's what I'm telling. Like that, frequency of the highest minus frequency of the lowest. So for the 3 tuning forks, 2 differences, which is 2 into 4. For 50 tuning forks, difference should be 49 into 4. But according to the given information in the question, highest tuning fork is 2 times of the lowest minus F lowest is equal to 49 into 4, sir. So what is the value of the 49 into 4? 50 into 4 is going to be how much? 200 minus 4. That is 196. So this is the value. Now what is that means? Lowest frequency is going to be the 196 hertz. So what is your highest frequency will be the highest frequency is going to be the since 2 times of the lowest frequency. It should be equal to the 392 hertz. Okay, these are the highest and the lowest frequencies values. So please be careful of these type of the questions. Now this is your promo code. You can get the discount by using this one for the subscription. Now coming to the questions need to be solved by the students. So thinking me as a student, I'll go for the solving here itself. First one, two vibrating tuning forks produces progressive waves given by this is your first progressive wave, this is your second progressive. So what are their frequencies? He's asking the tuning forks are being held near to the ear of the person. He's asking number of beats. So for the number of beats, I need the frequencies F1 and F2. So how can I get that particular thing? That is omega 1 is equal to 500 pi. This is from the first relation. Omega 1 can be written as 2 pi f1 is equal to 500 pi. Remove the pi. So f1 is equal to 250 hertz. Your first frequency. Similarly, second frequency omega 2 can be written as an phi naught 6 pi. From here, it can be written as an 2 pi f2 is equal phi naught 6 pi, and the f2 value is going to be the phi naught 6 by 2, or this should be equal to the 253 hertz. Then what is the number of beats? That is delta f is equal to f2 minus f1, which is 253 minus 250, which is equal to the 3 beats per second. So out of the A and B, it should be one option. He is also asking the maximum and minimum equal to ratio of the maximum to minimum. He is asking. How can you find the ratio of the maximum intensity and the minimum intensity formula? The maximum intensity by I minimum can be written as, and this is A1 amplitude, A1 plus A2 whole square by, that will be the A1 minus A2 whole square. So your A1 plus A2, in the sense the amplitudes, A1 is going to be the 4 and A2 is going to be the 2 here. So that means it should be the 4 plus 2 whole square by, it is 4 minus 2 whole square, which is in the sense 6 whole square, 36 by 4, that is equal to the 9 is to 1. So maximum, this is your answer. So B will be your option. Now coming down to the next one. Fifth overtone of closed pipe is to be in unison. Unison means resonance. Resonance means frequency is same. Is equal to the third overtone of the open organ pipe. What do you mean by fifth overtone of the closed pipe? Closed pipe will be the ratio of frequencies ratios. 1 is to 3 is to 5 is to 7 is to 9 is to 11 is to 13. It is your first overtone 3, 5 will be second overtone, 7 will be third overtone, 9 will be fourth overtone, and 11 is going to be your fifth overtone. That means it should be how much? Formula will be 11V by, since it's a closed pipe, 4L of the closed is in unison. That means this frequency is equal to the frequency of the third overtone of the open pipe. Third means third of overtone means fourth frequency. FV 4V by 2L. Open pipe. Okay. So it's going to be the 2L situation. So let me erase this one. Great. So this is going to be LO. Now he is asking what's the? He is asking the length ratio of the length of the open pipe, that is L naught by LC he is asking. So L naught by LC, this I'll cancel over here too. So L naught by LC is equal to, this is going to be the 8 by the 11 will be coming in the denominator. This should be your thing. That means your option D is your answer for this one. So this is the main important thing that you need to remember, which overtone is which harmony. Now coming to this one. Now, two closed end pipes when sounded together. They are the two closed end pipes when sounded together produces 5 beats per second. Okay. They are both the pipes are the closed end pipes only. If their lengths are the ratio 100 is to 101, then what will be their fundamental notes they are asking. Okay, fine. So they are, what is the frequency formula? Frequency, if I write F1 is equal to, since they are close to pi, V by 4L1, and F2 is going to be how much? V by 4L2. So now if I go for the ratio of this one, F1 by F2, or from this one, you can say that F is inversely proportional to the length here. Whatever it may be. So F1 by F2 is equal to how much it should be, sir? L2 by L1. Okay, and your their lengths are in the ratios. How they are in the lengths are in the ratios, sir? There he has not provided any ratio, so I'm going for this one 100 by 101. If I multiply this one with the 2, then it will be the 200 by 202. So that means they should be in the ratio of this one. So out of the given options, which options are going to be satisfying this ratio? That is clearly it's an option D, which is 500 by 505. I can write it as an 5 into 100 by, this is 5 into 101. So which option is going to be the better option in the given situation is option D. Now, next one, the fundamental frequency of closed pipe is going to be this much. And that means V by 4L is equal to 220 hertz. This is the information he has been given. Now, when 1/4 of the pipe is filled with water, that means you're closing the 1/4 of the pipe. So, what is the remaining length of the pipe? L remaining is equal to L minus L by 4 is being closed, which is 3L by 4. This is your remaining length of the pipe. With this one, what is the fundamental frequency he is asking? Then it will be the F dash is equal to V by 4 times of 3L by 4. This is your new length. Where this one cancels, it will be the V by 3L. We know from the first relation, V by L can be written as an 4 times into 220. Okay, so this is the information that we are having here, sir. So what can be the case? This is 1 by 3 into frequency of the first overtone of the pipe, closed pipe he is asking. So this is your fundamental frequency of the pipe. Frequency of the first overtone means is equal to 3 times of the fundamental frequencies, right? It's an which pipe? Closed pipe. So it is 3 times of the fundamental frequency, which is 3 into V by 3L. 3 goes up, which is equal to the V by L. What is your V by L is 4 into 220. What is 4 into 220 is 880 hertz. So this should be your answer. Now coming to the another one. A pipe at both ends produces a note. A pipe at both ends produces a note of frequency. Open at both ends in the sense it's an open pipe only, obviously. So open at both ends like this. It is producing a frequency of note F1 fine. When the pipe is kept with 3/4 of its length lower, that means you are closing the 3/4 of the length with the water. That means you are converting the horizontal pipe or the length of the pipe L from L minus 3 by 4th of the L, which is equal to the L by 4. So this is the new length. He is asking F2 is going to be how much? So F2 is equal to similarly V by 4L. But the new length is L by 4. 4 gets cancelled, so it's going to be the V by L. But what is your V by L value, sir? It's an open pipe, so F1 will be equal to the V by 2L. So this is going to the V by 4L. He is asking the F2 by F1 is equal to how much? So that comes out to be substitute their corresponding ratios. You should be getting whatever may be the answer. This is going to be the V by L by V by 2L. So now whatever you will be getting, that should be your answer.